Multiplication of radicals. In multiplying radicals, we are going to encounter three different cases. The first case is multiplying radicals of the same order or index. In this case, there will be different radicand, but same index. For number 2, we're going to multiply radicals with different indices, but same radicand. So this is the opposite of the first case. They have the same radicand, but look at the index. They have different indices. Last is binomial radical expressions, where we're going to use distributive property to solve for the radicals. Or you can also have FOIL method here. So let's start. Multiplying radicals of the same order or index. Apply the rule nth root of a times nth root of b equals nth root of ab. So we're going to answer letter A. First, we have your 3 cube root of 2 times 4 cube root of 7. So you multiply first the coefficients. That will give you 12. And then here, we have your cube root of, multiply the radicand, 2 times 7, that is 14. This is your answer for letter E. While for letter B, we have your square root of 2a times square root of 2ab. So I just multiply all of the radicands of this 2a times ab. So this will give us 2a squared b. And then since we have here a squared and the index here is 2, we can now put a outside the radical sign. So this a, then square root of 2. That's the answer for letter B. Multiplying radicals with different indices but same radicand. If the radicands are the same but different indices, you have to change them into similar index. So that's our goal here, to have similar index. So on our first example, we have here cube root of 2 times square root of 2. Since they have different indices, we need to make sure that they arrive with the same index. And to do that, let's first transform them into exponential form. So cube root of 2 can be changed to 2 raised to 1/3 times, then square root of 2, that is 2 raised to 1/2. Next, since they have the same base, we can combine them like this one. Copy the same base, and then we can add the exponent. 1/3 plus 1/2. Now, in this process, you just need to apply LCD to get the equivalent or the sum of 1/3 and 1/2. And to do that, you can have here a scratch. 1/3 plus 1/2. And of course, I can use the LCD 6 for them. 6 divided by 3 times 1 will give me 2, plus 6 divided by 2 times 1 will give me 3. So the answer here is 5/6. So we just need to change this sum to 5/6. So 2 raised to 5/6. And then let's transform it back to radical form. So the denominator, which is 6, becomes our index. The 6 root of 2 raised to 5. Or you can still simplify 2 raised to 5 as 6 root of 32. So you can also have this answer. So allow me to erase this sketch. Now let's go with the next question, which is B. 3 cube root of x times 2 square root of x. Again, they have the same base, but they have this different indexes. So to solve for this one, first combine the coefficients. This will give us coefficient of, allow me to have here 6, then cube root of x times square root of x. And then we transform that to exponential form. So this becomes x raised to 1/3 times x raised to 1/2. Then we combine these two bases, which will give us 6x raised to 1/3 plus, this 1/3 plus 1/2. Then as you can see, we already solved for 1/3 plus 1/2, which will give us 5/6. So 6x raised to 5/6. Then transform this to radical form. And remember, this denominator 6 will just contain x as its radicand. So we're going to copy the coefficient outside the radical sign. And then only x will be put in the radical sign. And don't forget the index 6. And then x, 5 in the numerator become its exponent. So this is the answer for letter B. Next. Binomial radical expressions. Binomials can be multiplied using distributive property or applying the rule of special products of algebraic expressions or binomials. Let's start with letter A. We have here 2 square root of 3 times 4 square root of 7 plus square root of 2. So just distribute the terms here. 2 times this one will give us 8 square root of 21. Again, the process here is to multiply the coefficient by the coefficient. 2 times 4 is 8. And then the radicand to radicand. Since they have the same index, you can just multiply the radicand. 3 times 7 is 21. On the second term, we're going to have here plus 2 times the coefficient here, which is 1, will give us 2. And then the radicand times the radicand will give us 3 times 2, which is 6. And you're done. This will be your answer for letter A. What about letter B? For letter B, we have here 2 binomials. So meaning we're going to apply FOIL method. So, or you can also have here some special product rule to easily answer this one. But for a general process, I'll be using FOIL method here. B, I have here square root of 5 plus 3, and then times square root of 5 minus 3. I'll show you the step method using FOIL method. So square root of 5 times square root of 5 will give me square root of 25. Square root of 25 will give you 5. Next, square root of 5 times negative 3. Of course, this is a whole number, so this will just be the coefficient of our term here, which will give us negative 3 square root of 5. Then for the inside, 3 times square root of 5, so plus 3 square root of 5. Then for the last term, positive 3 times negative 3 will give you negative 9. So here, as you can see, we have your similar radicals. So negative 3 plus 3 will give you 0. So you can just remove these radicals. This will be cancelled out, which will give us 5 minus 9 or negative 4.